Alright, ladies and gentlemen, welcome back. This is our last little thing here before we get to our keystones. So we're going to take a look at probability today. Alright, so got a lot of stuff going on here. Let's take a look and roll from there. I'm trying to get this to zoom in a little bit. It's not doing that. There we go. Kind of. Whoa. Alright, so probability of an event is the likelihood that the event will occur. It can be expressed as a fraction, a decimal, or a percent. Alright, so there's examples over here on the side. For example, the probability of a 5 on a 6-sided die is 1 out of 6, 0.1666 repeating, or 16.66 repeating percent. Outcomes are all possible results of an experiment. So if I'm talking about a 6-sided die, your only possible outcomes are 1, 2, 3, 4, 5, and 6. There's no other possibilities. Alright, an event is a collection of outcomes. Okay, favorable outcomes are the ones that you wish to occur. Here's the most important thing probably right here is theoretical versus experimental. Theoretical is what should happen. In theory, when you roll a die, you should get a 5 1 out of 6 times. In theory. Okay? Experimental, we rolled the die 8 times and you saw 3 5s. That's a 3 out of 8. That's not 1/6. Experimental, you don't know what's going to happen. I mean, it should technically be close to this, but you never really know. Dependent versus independent. Dependent, one event affects the other. So if I'm picking an ace out of a deck of cards and I don't put it back in the deck, I go from 52 cards in the deck down to 51. So it affects everything. Independent is when I pick out that ace in that deck of cards, put it back in.
Mr. Fitzgerald, please call extension 1122. Mr. Fitzgerald, please call extension 1122.
Please call extension 1122. Okay, so now the events, let's see, replacement occurs when your outcome is put back into play, or the non-replacement is when you keep it out. All right, so let's take a look at some examples and go from there. You toss 2 coins. What is the probability that both are heads? Okay, so the first time you flip the coin, the probability of you flipping a coin landing on heads is 1 out of 2. The second time it's 1 out of 2. Okay? So what you want to do then is you want to grab your calculator. Okay? This is where understanding fractions on the calculator will help you big time. I can do 1/2 times 1/2. Okay? And you always want to try and leave it as a fraction. So math, enter, 1/4. So the probability of getting heads both times is 1/4. Alright, you toss 3 coins. What's the probability that you get at least 1 tail? Alright, this one's a little bit more involved. Alright, oh, it says up here, sorry, I just read the directions here. As a fraction, percent round to the nearest hundredth. So this is 0.25 as well. So you get both. Alright. What's the only time flipping 3 coins when you won't get a tail? That is when you would get 3 heads in a row. Okay? So the probability of you getting 3 heads in a row is 1/2 times 1/2 times 1/2. Okay, so let's take a look real quick. 1/2. 1/2, 1/2, which ends up being 0.125 or 1/8. So if you want to know of getting at least 1 tail, 100% of the outcomes is 1. We do 1 minus 0.125. Okay, so if I do 1 minus 0.125, we end up with 0.875. Okay, or 7/8. And I do realize I said round the nearest hundredth, so this would be 0.88. Okay, so it's easier to do it that way instead of adding all the other ones up. It's way more difficult the other way. Okay, an algebra class has 17 boys and 15 girls. One student is chosen at random from the class. What is the probability P that the student is a girl? Okay, so you want the favorable outcome on top, which is the girls, which is 15. Over your total amount of students. 17 plus 15 is 32. So if I go ahead and do that, 15 divided by 32, 0.47. Okay, or if I change that into a fraction, we're looking at 15 over 32. Awesome. Okay, very, very cool. All right, so we got a few more here. Number 4, a number cubed with sides labeled 1 through 6 rolled 2 times. What is the sum? And the sum of the numbers that end face up is calculated. What's the probability that the sum of the numbers is 3? All right, so something to think about. Rolling everything over my desk. Okay. If I have 6-sided die, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If I roll a 1 to 1, the sum is 2. If I roll a 1 and 2, the sum is a 3, all the way down. Here, it's this way. You guys can make this up really easily. Okay. I mean, you're literally just adding each number each time as you go. And then here we got 7, 8, 9, 10, 11, 12. There are 36 total possibilities here. 36 total. So they asked you here, what is the outcome? What's the probability that the sum of the numbers is 3? How many 3s do you see inside this box? 2. So it's a 2 out of 36, or a 1 out of 18. Hey, chances are they'd probably give this to you on the Keystone, but on the off chance they don't, you saw it took me like 30 seconds to do that. Okay, and you guys can easily make that as well. You do a 1 through 6 going down, 1 through 6 going across. Number 5, a bowl contains 2 red chips, 4 blue chips, 3 yellow chips, and 1 green chip. 1 chip is drawn at random. What's the probability of drawing a blue chip? There is 4 blue chips. Out of your total, 2 plus 4 is 6, plus 3 is 9, plus 1 is 10. 4 tenths reduces down to 2 fifths, okay, which is 0.40, if you wanted to get either one. Number 6. A bag contains 4 red marbles, 6 blue marbles, 5 green marbles. 2 marbles are drawn from the bag and replaced after each draw. Find the probability of drawing a red marble and a green marble. So, your red is 4 out of, my grand total is 15. 4 plus 6 plus 5. If I put it back, there's still 15 marbles there. So the green marble is 5 out of 15. Okay? I don't want to think too much, so 4 out of 15, parentheses 5 out of 15. Okay, 0.09, or 4 out of 45. Wonderful. Good stuff. Okay. A bag contains 4 red marbles, 6 blue marbles, and 5 green marbles. The 2 marbles are drawn from the bag and not replaced after each draw. Find the probability of drawing a red and a green marble. Okay, so it's the same problem, but basically there's one big difference. The 4 out of 15 stays the same. If you keep the red marble out, you no longer have 15 marbles in the bag. Now you have 14. Okay, but there is still 5 green marbles, so it's almost the same problem. Okay, the only thing different is I'm changing that to a 4. So the probability goes up a little bit. This goes to a 0.10, or 2 out of 21. Okay. All right, a few more. A bin contains 8 blue chips, 6 green chips, and 2 orange chips. Find the probability of choosing a blue chip and an orange chip with replacement, meaning you're putting it back. So you've got blue, which is 8 out of 16, and then an orange, which is 2 out of 16. Okay? So again, I'm just going over here, 8 over 16, parentheses 2 out of 16. Please be careful and make sure that we're putting parentheses around everything. 0.06, or 1 over 16. Okay, cool. Find the probability of choosing a green chip, then an orange, then another green without replacement, and you're keeping it out. So green chip is 6 out of 16, and then an orange chip would be 2 out of 15, And then if I want another green one, okay, I'm now down to 5 out of 14 because I already took one of the green away. So it's not more difficult. Take my calculator out. 6 out of 16, 2 out of 15, 5 out of 14. Just make sure everything's in parentheses. Math, enter, enter. 0.02 or 1 out of 56. Okay. Find the probability of choosing either a blue or orange chip. Okay, so you add the blue and the orange together. I've got 8 blue and 2 orange. That's 10 out of 16. Okay, so 10 out of 16. 0.63 if I'm rounding to the nearest hundredth, or 5/8. Okay. An experiment is broken up into 2 parts. In the first part of the experiment, a penny is tossed in the air. If the coin lands on heads, then the coin is flipped a second time. If the coin lands on tails, and a 6-sided die is rolled, what's the probability of getting exactly 1 head? So, if it lands on heads, the coin is flipped a second time, right? If the coin lands on tails, and a 6-sided die is rolled. All right, so in order for it to land on heads, you want 1/2. Okay, and then if it does land on heads, the second time you flip it, you want it to land on tails. So that would be a 1/2 again. So 1/2 times 1/2, 1/4. Okay, because we don't want to roll that die. It says only once landing on heads. Okay, now referring back to number 4, a number cube with sides labeled 1 through 6 rolled 2 times, and then the sum of the numbers that end up is calculated. Okay, this is going back to the little chart that we made up. Okay, what is the probability that sum of the number is less than 6? So all you're doing here is less than 6 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You would do like 10 over 36, and you'd reduce it down 5/18. Greater than 12. Is there any number here that's greater than 12? No, because 12 is the largest number, so there is a 0% chance of that happening, which is fine. 11, there are 2 of them. 2 out of 36, 1 out of 18. And then for an 18, there is no 18 as well, so that's going to be 0. Okay, last 2. A die is rolled, what's the probability the number is even and less than 4? Okay, so the only even number less than 4 is 2, which has 1 outcome, 1 out of 6. And then a die is rolled, what's the probability the number is even or less than 4? So it's even or, so even would be 2, and then less than 4 would be 1 and 3. So that's 3 possibilities, 1, 2, and 3. So that's 3 out of 6 possibilities, or 1/2. All right? Okay. So that pretty much wraps up probability. There's plenty more to go with it. As always, keep up the good work and good luck. We're all counting on you.